In this lesson, I'm going to go over the linear inequalities, just graphing one at a time, and then a system of linear inequalities. But first, what we need to understand is we're going to graph a linear inequality just like a linear equation. So we want to use the format of y equals mx plus b. That way we could see the slope and the y-intercept, except we're now going to see these inequality symbols. So when we do see the inequality symbols, we'll just say of greater than and less than. And we always want to get y on the left side. So if we're looking at like y is greater than x plus 6, or y is less than, we'll say 1/2 x minus 4, whenever we just see the greater than or less than, we're going to draw a dotted line or a dashed line. And then when we see the greater than or equal to, less than or equal to, this is going to get a solid line. So this is going to tell us the types of lines we're going to see. Now the difference here is because it's greater than or equal to, less than or equal to, it's the or equal to part here that points on the line are included. When it's a dotted or a dashed line, the points on the line itself are not included in the solution region. But now when we're looking at, let's say, greater than or equal to, we're going to shade above the line. But if our line is vertical, we don't have an above or below a vertical, we would shade to the right of a vertical line. So we're going to shade above the line or to the right of, if our line happens to be vertical. And then if we see a less than or equal to, we're going to shade below the line or to the left of the line if it's vertical. I'll just say shade below or to the left. All right, so let's go ahead and practice a couple of these, and then I'm actually going to bring up a Desmos graph as well, just to see what we could do to answer some of those questions when you have examples like that. All right, so let's say we have y is less than -1/2 x plus 3. And then let's do a system right now. We'll do y is going to be greater than or equal to, we'll just say x minus 4. So what's nice about both of these is that they're in slope-intercept form. We don't have to rearrange anything. I'm going to start with the red inequality here. So my y-intercept is at 3. And then I have a slope of -1/2, so I'm going to count down 1, 2 to the right, down 1, 2 to the right, or up 1, 2 to the left. Now, if you notice, it's a less than, not a less than or equal to, so I'm going to have a dotted line. And because it's also less than, I'm going to shade below the line. So I like this feature on here where I can just draw a dashed line going like this. And now what I'm going to do, I'm not going to shade the entire thing. I'm just going to make little markings here. So this is indicating every point that is below my dotted line here. All right, now for the second one, I have a y-intercept of -4. And I have a slope of +1. So I'm going to go up 1, right 1, or down 1, left 1. Because it's greater than or equal to, I'm going to have a solid line. And I'm going to shade, because it's greater than, I'm going to shade above. So if you remember, a system of equations shows where graphically where two lines intersect. Now we could solve a system of equations without graphing. We could solve by the substitution or elimination method. However, a system of linear inequalities can only be solved graphically because we have an infinite amount of solutions, and we show that solution region where the shaded regions overlap. So I'm going to shade above the line, so that's going to indicate everything here. Now where these two shaded regions overlap, I'm actually just going to color in green. So that's going to be this area right here. So this is the solution region. Again, it's where the two regions overlap. Now I can go ahead and pick any point in this overlapping shaded region, in the solution region. So I'm actually going to pick, I know it's kind of hard to see with the shading that's right here, I'm going to pick this point right here. So if I count 1, 2, 3, 4 to the left, and then 3 down. So that's 4 to the left and 3 down. So I'm going to see if this point is a solution to this system of inequalities. So what I do is I first check in my first equation right here, y, which is -3, should be less than -1/2 times -4 plus 3. So -3 is less than, this will give me a +2, plus 3 is 5. -3 is less than 5, so that checks. Next, I'm going to substitute the ordered pair into the second inequality. Y again is -3, should be greater than or equal to, I have a -4 minus 4. So -3 is greater than or equal to, this will give me a -8. So that tells me the ordered pair, the point that I chose here, is a solution to both of these. Now, if I picked a point, let's say up here, and it's only in the shaded region for my second inequality, it's not going to satisfy both. If I picked a point on the line, same thing. It's not going to satisfy my first inequality because it should not be included there. Now, I could pick a point right on the line here because it is included. That would be also in the shaded region. But if I picked a point over here, it's only going to work for the first inequality and not the second one. And I don't know if I said this, but the point up here would only work for the second one, not the first one. All right, so let's take a look at a graph on Desmos. So I went ahead and just graphed these two. Now, what I also want to go ahead and review are vertical and horizontal lines. So I'm actually going to take this one, the second one, off for right now. When I go ahead and I typed in y is greater than or equal to 2x minus 1, notice I have a solid line here, and I'm shading above, so everything that's above the line. Next, this was just y is less than 4. When you don't see an x, when it's just y is either equal to a number or y is less than a number or greater than a number, it's going to be a horizontal line. So there's my horizontal line. Notice it is just less than, so I have a dashed line here, and I'm shading below. So my solution region is where the two shaded regions overlap. You can see it's a little bit darker than just this light green over to the right here. And again, I can pick an ordered pair. Let's say I want to type in, I'm going to pick -6, 0. So here's my point, and that would be in the solution region. Any other point just up here in the pink or in the lighter green would not match, and then absolutely no point up here in the unshaded region. So I'm good with picking any point not along the green dashed line. I could pick a point on the red or the pink solid line or anywhere in the shaded region, and then that would be a point. And then we could also check. If I have -6, 0, 0 is in for y. And -6 times 2 is -12, minus 1 is -13. So 0 is definitely greater than -13. And then my y is less than 4. All I have to do is substitute in 0. 0 is less than 4. So you could check just by picking in the shaded region here, or you could pick a point and then substitute it back into both original inequalities. All right, let's take a look at just writing something in slope-intercept form. All right, so this was an example of one of the pictures that you just sent me. So first what we want to do is get this in slope-intercept form. So all I need to really do is move that 3x term to the other side. So when I do that, y is going to be less than +3x plus 5. I'm going to pick another example, not quite like number 2 in the example here, but something similar. Let's say I have a 4x minus 2y is less than or equal to 10. Now this we have to apply when we go to divide by a negative number. Our inequality sign is going to switch. So just like the last example here, I want to move the 4x over to the other side first, but this negative, this minus is going to stay in front of the 2y. So we're going to have a -2y is less than or equal to, this will become a -4x plus 10. I always want to put my mx term first before my y-intercept. But now when I go ahead and divide by a -2, I have to flip my inequality sign. So I want to do that first so I don't forget. And it's only because we're taking the opposite. When we divide or multiply by a negative, we're taking the opposite, so we have to flip the sign. We need the opposite sign to keep the statement true. The only reason we don't do this with an equal sign is because when you flip an equal sign, it doesn't look any different. Two sides are still equal. So here I'm now going to get y is greater than or equal to, this will give me a positive 2x and then a minus 5. So now we just want to go back and describe what's going to happen here. So with this first example, because it's just less than, we're going to draw a dotted line or a dashed line. And because it's less than, we're going to shade below. So I believe you have to do some matching here. Over here, it's going to be a solid line. And we will shade above because it's greater than. Okay, and then one last example I want to go over, just refreshing with vertical lines here. All right, so let's say I have x is less than or equal to 2, and then I have y is greater than, say, negative 3. All right, so right here, x is less than or equal to 2. Whenever we see an x is equal to a number, when there is no y, it's not in your traditional slope-intercept form. This is going to be a vertical line. It's also going to be a solid line. And then when we go to shade, I want to graph it first before I discuss how we're going to shade. So this is going to be a vertical solid line going through 2 on the x-axis. So here's my line. Now I don't have an above or below, but I do have a right or a left. Now since it's less than, we're going to shade to the left of this. So that is everything over here, up to and including points on the line. All right, when I go to graph my second inequality, this is going to be a horizontal line. And with horizontal lines, we either definitely shade above or below here, so we're going to shade above. And because there is no or equal to, this is going to be a dotted or a dashed line. So here, I'm going to draw a dashed line going through negative 3 on the y-axis. And I'm going to shade everything above. So that's going to be everything up here. All right, so my solution region is where they both overlap. So it's everything up here. And again, I could pick a nice ordered pair. One easy one to pick when you can. Pick the origin. It's always the easiest. So if I were to test 0, 0, if I were to substitute it back into the first one, 0 is less than or equal to 2. And then 0, for my second number here, 0 is greater than negative 3. All right, so these were a few examples like the images, the pictures of the problems you sent me. I'm going to go ahead and work out the solutions to each of the problems, and I'll send them to you in a different video that you could watch afterwards, or still feel free if you have any other questions, just let me know. Hope this helps.